I know I actually tried compressing the videos and it was still too big, so I'll go to the tech center and see if they can help me. Or the tech building. Yeah, I usually try with OneDrive and everything, but nothing. Still too big, so. Yeah, I know. All right, so for B, move that up a little bit. So you have the limit of x over 5x to the third as x approaches 0. Okay, so we don't have a left, we don't have a right. So when you don't have a left or right, you have to get it from both sides. Okay, so I give it a little extra room since I'm. Okay, so let's say this is our x. This is our x over 5x to the third. Okay, so we know it can't equal 0, so we'll just leave that blank. So as it's approaching from the right, we already did that, but we'll fill it in anyway. You have 2, which is 0.05. Uh-oh. You have 1, which is 0.2. You have 0.01, which is 2,000. And 0.001, which is 200,000. Okay, so now if we're going from the left, I'll put in -2, -1, -0.01, and -0.001. Uh-oh, move that up. All right, so if we plugged in -2, we actually end up with 0.05. Because you have -2 over -2 times -2 times -2 is -8. So you have negative over negative, which would be a positive. So every negative you plug in would just cancel out. Or if you cancel out the x's, you'd have 1 over 5x squared. So the negatives will always cancel out. So. Okay, so if you plugged in -1, you'd end up with 0.2. If you plugged in -0.01, you'd end up with 2,000. And -0.001, 200,000. Okay, so either from the left or from the right, as you get closer and closer to 0, the limit is going to equal infinity. Okay, and that's simply because the limit from the left and the limit from the right are equal. All right, so any questions on that one? All right, make sure anybody's still writing. Okay, everyone's done. Yep. Okay, so let's say, for example, you wanted to find the limit say of f of x equals x minus 2 over x squared times x plus 4. Oh, I forgot to put limit. I don't know why I put that one. Oh, I'll start a new page since it's early in the problem. So it should be the limit as x approaches 0 from the right of x minus 2 over x squared times x plus 4. And for b, the limit of x minus 2 over x squared times x plus 4 as just x approaches 0, period. Okay, so remember for A, all they're asking is for the limit from the right. So you don't have to worry about any values from the left, at least for this one. For B, again, you have to go left and right because they're just asking for the limit, period. So those limits have to be equal in order for that to exist. So the limit of x minus 2 over x squared times x plus 4 as x approaches 0 from the right. Go ahead and create our value table. So you have x and x minus 2 over x squared times x plus 4. Okay, so as you get closer and closer to the right, let's say we have 5. You don't have to start this far. I won't either. I'll just start with 3. Say 2, 1, say 0.01, and 0.001. Okay, so getting closer and closer to 0 from the right. Okay, so if we plugged in 3, we'd end up with 0.0158, and that's just kind of a rounded number. It just keeps on going and going. Okay, if we plugged in 2, you get a numerator of 0, so we just end up with 0. If we plugged in 1, we'll have negative 0.2. If we plugged in 0.01, we'd end up with negative 46.3. And if we plugged in 0.001, we'd end up with negative 499,625 and some decimal point, but give or take, really close to the negative 500,000. Okay, so as you can see, as you get closer and closer to 0, that number just keeps dropping lower and lower and lower. So the limit of x minus 2 over x squared times x plus 4, as x approaches 0 from the right, is equal to negative infinity. Yes?
So will there be any way to numerically evaluate this, or is the only way that we can do this through a table?
You can. It's one of those where if you know the values are positive, you can say, let's see, for any value, because you know if you plug in 2, you get a numerator of 0.
Right.
So that's a value of 0. So you say, okay, anything less than 2 will give you a negative number on top and a positive number on the bottom.
Which will ultimately make it negative.
Exactly. So it'll be negative.
So
that's how we do it, at least for 2 and 1. The only thing is when you get from 2 to 1, when you start dealing with the decimals, like 0.0001, it's kind of hard to do those in your head.
Right.
So that's the only thing. But because sometimes you'll have a graph that may, for 2 and 1, it may go up, and then when you start getting to the decimals, it may shoot back down. So that's why I would really do the decimals first, because it gives you a better idea of where you're going.
Gotcha.
Does that make sense?
Yeah.
Okay.
So that's pretty much saying if it approaches 0, it's never going to hit 0.
Mm-hmm.
Then at 2, it hits 0.
Oh, no, the denominator will never hit. It'll never hit a denominator of 0. So if you plug in 2, that just means that your x value is 2. Yeah, so yeah, your x value would never hit 0. All right. Any other questions? All right, so let's do problem B. Slide that up a little bit, which is your limit of x minus 2 over x squared times x plus 4 as x approaches 0, period. No lefts or rights. Okay. So we don't see any pluses or minuses or from the rights or as it approaches from the left. You have to do both sides. Okay, so this is your x, and this is your x minus 2 over x squared times x plus 4. And I'll just put the 0 right there in the middle, because we know that's going to be undefined. Okay, we already did from the right, so we can just plug those in. Uh, 0.01, negative 46.3, 0.001, should have made that bigger. Negative 499,625. Okay. Now if we're approaching that from the right, let's say we start with negative 2, negative 1, and since we're limited on space, I'll go right to negative 0.001. Move that up a little bit. All right, so if we plug in negative 2, we'd end up with negative 0.5. If we plugged in negative 1, we actually end up with negative 1. But if we plugged in negative 0.001, we'd end up with negative 500,375.1. So once again, those numbers are just getting smaller and smaller and smaller, closer and closer to negative infinity.
So will I ever have a positive and negative infinity?
You just read my next example. That's it. Okay, so the limit, x minus 2 over x squared times x plus 4, as x approaches 0, is negative infinity.
Since you go to the third class, since I can come in, isn't it? Like, if, for the next one, at least.
Oh yeah, with this one, your vertical, well, you don't really need to know the vertical asymptote for this one.
Next one I'm talking about, because.
Oh yeah, but that one, the next one, yeah.
Next one.
Yes.
You said if it's approaching 0 from either side,
Mhm.
they have to be equal.
Yes.
For them to exist, right?
Mm-hmm.
But that chart isn't quite equal.
No, but the number that they're approaching is the same. So both of them are just approaching really, really big numbers.
Oh, I see.
Yep. So this one, if you notice, it's near 500,000. You notice negative 500,000. You notice this one is really close to negative 500,000. So they're both can approach negative 500,000, but they just keep going. That's the only thing. Does that make sense? Okay. All right. Any other questions on this one? Yes.
So if they're like both approaching negative infinity, would that mean they exist or don't exist?
That means the limit is negative infinity, but there is no limit. So when it's negative infinity, that means it doesn't reach a certain point.
So it doesn't exist then? Would that
It-
even be a question?
The only time it wouldn't exist is when you have a limit, which is the next example, a limit that's infinity from one side and negative infinity from the other.
Okay.
That's when it wouldn't exist. Because in this case, the limit is either infinity or positive infinity, or negative infinity or positive infinity. So that would be your answer.
So if they're both negative infinity.
Yep, then your answer would be negative infinity. Yeah.
On the test and
Mhm.
stuff like that, are you looking for a table like that? Or,
If you can show me another way to show the pattern, then I'd take that. But the
Like if we
table's
just-
probably the easiest.
if we just go just straight to like, negative 0, 0, 1 and positive 0, you know?
Oh, you wouldn't have to like start from if you went like 0.01, 0.001, and okay, well, this is it. Then I'd be 2 or 3 on each side, and I'm good with that.
Okay.
I just do that for visual effect. All right. Okay, so let's say, for example, pick a good one. Okay, let's find the limit, say for problem A, the limit of 1 over x cubed minus 1 as x approaches 1. Okay, I'll give you a minute to do that. I was going to do from the left and right, but I'm thinking you know how to do those. So we'll just make that as x approaches 1. Mm-hmm.
Usually when anything is, has to the power of an odd number, it would be pretty much one up, one down. Like having a negative. and
Yeah,
positive.
pretty much. That's kind of the pattern for that one. Unless it's removable, then it may change that. Clean that up a bit.
When we make our side numbers, the ones that you work down with, or
Mhm.
whatever you use to plug in,
Mhm.
do we have to, if say we're trying to get to 1, we're coming to 1 from both sides, do we have to get into the decimal numbers, or can we just leave them as 1, 2, 3, negative 0, negative 1, 2, negative 3?
It usually helps because I have seen some graphs actually as you get closer and closer they shoot up, and then when you start getting to the decimals, it's like they take a sharp turn down. So
try to
you may
stick with the
think
decimals.
exactly. You may think it's okay, like it's going towards infinity. Then when you start 0.1, 0.001,
So it's just
yep,
safer.
exactly.
Okay.
Are we either gonna be able to use calculators to determine those numbers?
Oh yeah, you can use calculators. yeah, if you want to use fractions, you could. Okay, so we know that the limit as x approaches 1 from the right is what? What did you come up with?
Positive
Infinity. But we also know that the limit 1 over x cubed minus 1 as you approach it from the left is, yep, it's negative infinity. Okay. Now this is what they call a two-sided limit, so of course when they don't go in the same direction, it doesn't exist. Oops. Yes.
So I thought we said that with infinity, a limit does exist, right? Or it's supposed to exist, but it's just infinity.
Yeah, it would just be infinity.
But it would still technically be set as a limit doesn't exist, right? Or do we just assume that?
Well, it's more along the lines of there is no limit because of how it just keeps going up or it keeps going down.
Okay, so
But in this case, you wouldn't put infinity only because one side is infinity and the other side is negative, exactly. So
Okay.
unless they're going, approaching the same either infinity or the same negative infinity, you would always want them going at the same point.
Gotcha.
That makes sense?
Yeah.
All right.
But because it's a two-sided, so the answer would be both of them, or the answer would be, doesn't have to be
Yep,
both?
does not exist.
Okay.
So,
That's what I was curious.
and most of the time you'll just see D and E or does not exist. Oop. Let me see, which one do they have that listed as? Yeah. All right, any other questions on this one? All right. Okay. So now we're going to talk about the intermediate value theorem. Okay. Now, just drawing it out on a graph, I'll give you kind of an example of it. Okay, so let's say you have some graph there. Okay, let's say this is 3, and we'll let this x value be 7. Okay, so let's say whatever your function is, if you plug in x equals 3, you end up with y equals 2. And if you plug in x equals 7, you end up with y equals 18. Okay? So what the intermediate value theorem says that if you pick any number between 3 and 7, and we'll just call that number C, then at some point, as long as this graph is continuous, at some point on that graph, there exists some value f of C. That would be between, in this case, 2 and 18. Okay. But if you have the general description, let me write this out. So for every x value between 3 and 7, we'll call it C. There exists an f of C between, let's say, y equals 2 and y equals 18. And again, that's assuming if the function is continuous.